you know, whatever. It's just, I think you guys are actually going to have a little bit of fun today, believe it or not, even though I probably am sounding a little flat right now. Um, so let me, now that we're live streaming, let's go to it here and get into here. Hopefully you're seeing the any day now canvas. Let's wait for it to react here. There it goes. Let's see. We already did week 7. We already did that quiz. So here we are up to lab quiz on resistor networks. So let's open this one up. And then, so there's a lot of multiple choice. So you can see the main goals here. Notice this first goal. I cannot stress this enough. If you only do simulations, you will think circuits work all the time. And you will think, yeah, whatever I do in the sim, it's never the same in the real world. There's always something a little quirky, like maybe some internal resistance to a battery is messing up your circuit, or the resistance of the wires, or some stray capacitance or inductance, or RF signals from a nearby radio station. In the real world, real circuits are less than ideal. We have been doing ideal circuits. When you make simulation circuits, those are ideal circuits. The real world is not ideal, as we all know right now. That said, that's one of the goals. The other is to get good at series and parallel elements, and also not only how they look in a picture, but also in real life compared to a schematic. So, right, just seeing pictures of schematics all the time, that doesn't mean you know how things are wired. So that's another thing, is like, which of these schematics is going to match which of these circuits, or yeah, things like that. And finally, I do want you to create simulations. Now, here's the deal. Times are different than regular times. We need to focus on what can be learned well, so that when you move to the next level, at least you know the things that you were able to learn now, and then you pick up the pieces later. So you are not going to be good at electronic circuit labs later. But if we can get you to identify circuits, recognize these things, you can learn the lab skills in a later class, but have excellent knowledge of theory and simulations, and at least being able to identify what things look like. So that's where I'm focusing my energies. What can we do well? These things. So let's do a really good job at that, and see that real circuits don't match that. Then in a later class, you can do real circuits. So let's do a quick walkthrough here. Maybe if this computer loads. So you'll get some ideas here. You could see right here, hopefully these pictures are good. And now remember, if you get a fuzzy picture, I expect you to kind of tough it out a little bit. But this is going to be one of these things. Is this the figure out what I did wrong type problems? The did I make a mistake, and if so, what is the mistake? And you can see there's a bunch of different answers here, so some of that kind of stuff. All right, so hopefully this will be a little bit easier than last week's horrible lab. You can see there's a couple of these. They're kind of blurry, but I think you could tell. So again, if you forgot how breadboards are used, there's a link to the video. Hopefully that link works. If not, we'll fix it. All right, let's keep scrolling down. So here you could see you could make a simulation. Now, I was going to have you make these with Phys, but I think it's going to be a lot easier to make them with Tinkercad. So Tinkercad is pretty solid. And it's free. So I think what I want you to do here is, I don't care if you use Phys, but Phys you have to do basically a manual scaling in your mind. So I would try Tinkercad here, and I'll put those links in there, or if somebody wants to, you can put the link in there in the chat for the Tinkercad site. So remember, each student should take the time to make sure they get Tinkercad to work, or whatever simulation you want to use. Because these are the kinds of things that will help you later if you have to take a circuits class. So why not get good with simulations now? And I happen to know, if you're going to take circuits at Hancock College and it's next semester, you're probably going to be using Tinkercad. So why not get a leg up on next semester, at least for a few labs, and every single student use this? I don't care if you share screen and show somebody exactly how to do it, as long as that other student doesn't just copy your Tinkercad. Just learn how to make the sims. I'll show you exactly how to do it. Okay. And maybe we'll do a live stream of that later. But anyways, yeah. So make a simulation. You can see there's some questions here. And this looks like kind of your big essay question, right? Yeah. So this is your essay question this week, where you're going to have to do the work and notice that things don't match up. And then we're trying to figure out, are these 1%, 2%, 5%, 10%, or over 10%? How do things match up to reality? And I think you'll find it's probably not less than 1%. All right. So yeah. And what is your perception? Obviously, this is a pretty touchy feely thing, but so write these up. And I think each student should do this. But again, work with a partner and bounce your ideas off of them before you turn it in. Oh yeah. Now this circuit puzzle number 4 is a good one. So this is something that I couldn't do in a regular lab that I always wanted to do to students. So the idea was I hid the power supply. So you have to use series and parallel rules to fight your way through this circuit. And I think what you'll find is this problem, fingers crossed, hopefully forces you to use the clever methods rather than doing the R equivalent and work backwards. So you remember yesterday I said, if you're a little bit clever, you can, do these things. I can help you be clever, but and you could talk with your partners. But I think there's some clever ways you have to fight through that circuit. So that one I hope should be fun. Yeah. All right. Anyways, and then there's yeah, good. Yeah, this one's really tough. So yeah, so there's a bunch of just kind of summary questions at the end. So again, I'm only going to look at the most recent summary. So if you guys need to do an essay, right, make sure you save that essay in Word so you can cut and paste it on each submission or whatever you got to do. So make your plans. When you make the essay, make sure you copy and paste it into each new submission. All right, just so all your stuff is together. And I think that's pretty much it. Basically, watch some videos, do some work. I'll stop the live. Well, you know what maybe I'll do right now is, if you want, I'll show you Tinkercad really quick. We'll see if I'm still signed in. And that way we only have one live stream that people have to watch. So if you're in here, hopefully I'm still logged in. Let's see, we got the chat right on. And then let's see, am I logged in? I don't know if I am. Circuits. So you can see I've made some really bad circuits here. I don't know. It looks like it comes up with its own names. But one of the things that maybe is a little bit spicy for you guys that you haven't done yet. So when you're using Tinkercad, you could search over here. So I'll do a breadboard, right? And you could bring out a breadboard over here, or you could bring out, whoops, let's delete that. You could try one of these mini breadboards. Can I get rid? Well, you can see I'm connecting with wires here. All right, I want to get rid of this thing. Hold on. Whatever. I'm trying to bring out a breadboard mini there. So you could do a small breadboard, and then you could come up to here, type resistor. Oh my gosh. All right, I think that's enough. But my point was, I wanted to remind you that you could actually do breadboards as well. And so you want to learn breadboards if you're going to be doing circuits. If you're going to be a mechanical engineer and you have to take a controls class, or an electrical engineer, geez, come on, or certainly as a physics major, you should learn how to use a breadboard as well. So rather than just connecting the resistors with wires, why don't you try simulating the breadboard? All right, so let's get out of that there. And I'll just leave it at that for right now, and I'll let you guys play around. Sorry, that was an uninspiring use of Tinkercad. But you could use the search to find the components you need. Search for a resistor or a power supply or a DMM. And so you could make simulations and dial in the voltages and compare them to the real life circuits and find out it's totally different.